Hello all, in this video segment we're going to talk about tetrapods. So far we've been talking about phylum Chordata, looking at the invertebrate chordates. Okay, so we know that all chordates at some point in their life share a notochord, postanal tail, a dorsal hollow nerve cord, and pharyngeal slits, even those strange cephalochordata and urochordata. Okay. We also talked about the vertebrates. So starting with the jawless fishes, the hagfish and the lamprey, which are here, these sister taxa, hagfish and lamprey. Okay. So these guys not just have basic vertebrae, but also have crania to help protect their more advanced brains. Okay. We looked at the chondrichthyes. So these are animals with a more mineralized skeleton and with jaws. So jaws is a huge innovation, allowing these animals to capture and subdue prey or to chew their food. And chondrichthyes still have cartilaginous skeletons, but they are more sturdy than what we've seen previously. We also looked at the fishes, including the ray fin fish, which were the first to start showing lungs or lung derivatives, in other words, the swim bladder. And so starting with the Actinopterygii, those ray fin fish, we see swim bladders, and that persists until we get to the lungfish, or Dipnoi, where that swim bladder has been modified into an actual lung. Okay, lobed fins. So there were two groups we discussed, the coelacanths, or Actinistia, and the Dipnoi, that both had those muscular, thick lobed fins, which paved the way for the tetrapods. So our tetrapods are named after their four limbs that have digits. There are three extant or living lineages that we're going to look at: the amphibians, the reptiles, and the mammals. So you guys might notice that class Aves, the birds, is missing off of this tree. And we'll talk more about this later, but that is because birds are actually deeply embedded in the reptile phylogenetic tree. Birds have evolved from a type of dinosaur, and so they are actually reptiles. So this tree is monophyletic, which means that the birds have to be in the reptile clade. So we're going to see other derived traits as we move along. So reptiles and mammals both share amniotic eggs, and we'll describe those later. And we know that mammals produce milk and have hair. So our tetrapods evolution, okay, we know that they have to transition to land. And to do this, they have to overcome several challenges, just like the plants did. So they have to have adaptations to help prevent desiccation or drying out. Okay, they have to have adaptations to help them move around on land and deal with gravity. And they have to have adaptations to help them reproduce on land so that their babies don't dry out and die. So many of the adaptations that help with this have already started to form in those lobe-fin fish. So the lobed fins are muscular and to some extent able to support the weight of the animal. Okay, there's a vertebral column, and we'll see that that is acted upon by natural selection and strengthened, as well as the hip and shoulder bones, okay, which help brace the limbs and allow for them to walk around. And there'll be adaptations like the amniotic egg, which allows animals to lay eggs on land instead of in the water because of the protective layers that the amniotic egg has. We'll see shifts in respiratory systems from gills to lungs. And then the skin coverings will change as well to help those animals be protected on land, as well as prevent desiccation and loss of water through their skin. Okay, keep in mind, all of these evolutionary steps are not need-based. Okay, this is natural selection. Variation is present in populations. Those adaptations that are best suited for land are selected for, and those animals are the ones that become more fit. Okay, so they're the ones that reproduce and pass on those adaptations more often in the population. Given enough time, millions of years, this can lead to speciation in these dramatic changes from fish to amphibian. And we also know that this did not happen all at once. Again, I mentioned this happened across millions of years. Okay, And we know that natural selection is the driving force. So keep in mind these characteristics of tetrapods line up with chordates. Tetrapods are chordates. And the derived characters that we're really looking at are these 4 limbs with digits and the weight-bearing skeletons. So that's all for this segment. I hope you enjoyed it.